Hello everyone. Right, I am Rukshan sir, Rukshan De Silva, a paper marking examiner. Right, teaching A-level chemistry for over 11 years now. Right, that is enough, no, about the introduction. Right, so I'm not that much to talk about me here. Right, it is all about chemistry. Right, okay. First of all, thank you for coming for our first lesson, inauguration lesson, right? So, first of all, I would ask you a question to begin with, right? So, if I am asking you that, give me a one method, right, which you has used to come up with the correct answer when you see the question in your question paper. Right, again I'm asking you a question, this kind of a question, right, and this is all about A-levels, right. I'm trying to give you some little idea about A-levels, right. I'm not that much talking about things other than chemistry. So let's to begin it, just give me a one method you had used to come up with a correct answer when you see the question in your paper, in your O-levels. Yes, this is going to be an interactive session, right? Yeah, you can give me answers, right? You have to interact with me, right? This is all about the discussions in chemistry, right? And you can ask any question, right, regarding chemistry. Any question, not from from this lesson, even from other lessons, you can ask any question regarding chemistry, right? This is I'm very keen to participating in these kind of discussions in chemistry, right? So yes, you have some opportunity here to come up with a good answer, right? A one method which you had used to come up with answer when you see the question in your question paper. Yeah, I'll tell you if you're not telling me, right? One method is actually you may have seen, you may have memorized the part in your textbook when you see the question. Right? When you see the question in your question paper, you may have that part of the book you have studied came to your mind. So with the use of that thing, just copy paste in the stuff at the book to your paper, right? You are able to come up with the answer. That is one method. Give me another method. Think of another method which you had used. Sorry, I didn't hear that. Sorry, I didn't hear you properly. Some technical error here. Sorry? Logically thinking the answer. Yeah, I got the idea, right? Logically thinking the answer. That is another method. Yeah. Okay. So that is the second method. Okay. Right. Logically thinking the answer. Right. Any other methods you had used? Lama, just interact with me. That is very helpful to convey our ideas to you as well and your ideas to me. Now we had discussed about two methods, right? One is just grabbing the stuff from your textbook, right, and just writing the same stuff, right? Even you are able to in your memory you are able to turn some pages as well, right, to come up with the correct answer, right? That is one method. So your friend told us another method, logically thinking about the answer. In which kind of subjects you have used that method, method, logically coming up to the answers, right?
Probably Max.
Yeah. Yeah.
Biology in some cases, when you consider heart structures and all.
Yes.
And even in history, some might be ironical, but history as well.
Yeah, of course, your friend came up with good answers, right? So that is the second method. That is the most important method. I'll tell you more about that thing after we are discussing about some other method, right? That is, we have discussed now 2 methods, right? What is the third one? If you are to remember, any other method you had used to come up with correct answers in your question paper? Yeah, you can try. You may have used your memory, you may have used your past memory in your class, right? So sometimes you can recall, right, the moment your sir or your madam or your miss, right, taught you the lesson, how she acts, what she told, what he told, right, when teaching you the lesson. You may be able to recall that moment in time inside the class, right, you were in, right, to come up with a correct answer. In so those cases, right, you say, "Ane api sir budu eva," right, like so those kind of things we'll say, no. So he's our God, he is my survivor, right? Such kind of words will appear from you if you had came up with that method for a better answer in your test paper, right? Those are 3 methods. Those are the 3 methods we had used, right? And here in A levels, basically, what do you think? Which method will give you the best results? The first method, second method, or the third one? For great results, good results, 3 years, which method will you see? Yeah, you have to come up with a combination, but mainly for a better results, you have to come up with the second method. In that method, it is like what you think, you just write. You are not thinking about what sir had said, what your madam had said, what your teacher had said. You don't think about that thing. When you are to coming up with the answer with the second method, logical approach, you are not thinking about what book says, right? What was there at your book? You are not thinking about that. You just write what you think. And surprisingly, you come up with the best answer. That is what you have done in maths. That is what you have done in maths. When you see the question, just to multiply the 4 with 6, you won't memorize the moment your nursery teacher taught that thing. You don't memorize the moment. You don't. The page of the book won't come to your mind where you had first multiplied the 4 with 6, but you just write what you think, and it is going to be your answer. It is the best answer. It is the correct answer, right? So that is the logical approach, right? So that is what we are. That is what I am supposed to give it to you, right? That is what we are aiming for in this class, right? I need all of you to come up with logical answers. I need all of you to write what you think, and I expect all of those answers are the correct ones, going to be the correct ones, right? That is what we approach here, right? That is why you need me, right? So because in A levels, right, we have textbooks, resource books are there, all the past papers are there, all the answers are there. So if you are able to come up with the first method to come up with the correct answers and do this stuff, then you don't need a teacher, right? So if you are going to use the third method, just only, right, depending on the teacher, that won't give you a good result. Because in A levels, it is not like in O levels. Most of the questions will be asked not directly from the book. not directly from the things at the book, not directly from the things at the resource book, right? In MCQs, basically there will be, every year there will be 5 questions. You have to think beyond the book. So to get a better result, good result, you should know how to think, right? So I am here to guide you and to give you the ideas of chemistry to come up with genius at that method, right? So that is the idea. So that is the small description or a small discussion, right, about the A-levels. So you will see in everything here you learn is coming up with a logical approach. I am giving you reasons for each and everything, almost everything, right? So first just participate these 2 classes and see the difference, right? We are coming up with always with reasoning. We are not just saying that is it. No memorizing, right? You can derive all the things happened or happening logically, right? That will be the approach in this class, right? And I am here to help you. You can ask any question. I'll be there to give you answers, right? So this is going to be a live discussion, right? And after the class as well, you can message me the questions and our team member will give you my WhatsApp number, right? So you can use that thing, right? And discussions are always allowed. That is how we develop our knowledge, right? Okay, let's start the session. That is the small discussion about our class. I think that is enough because I am not much discussing things other than chemistry, right? I love chemistry, so I love to talk chemistry. That's it, right? So let's start. Let's start with the first lesson, right? So let's start with the atomic structure, right? When the things goes on, right? I'll discuss the things at your A-levels, how the paper comes, what is the structure of the paper. Those things will be discussed when the class goes on, right? I'll start with the first lesson, atomic structure, right? Okay, let's begin. Before that, if anyone of you have any other questions to ask before the beginning of the class, yes, you can ask, right? If not, we can start the lesson now onwards. You can put it in the chat box, right? Better. So we'll concern about those things, right? And let's start the lesson, the atomic structure, right? Okay. This is the story of the atom. This is all about the story of the atom, right? Atomic structure. So we have a question, right? So this class is totally conducted online. But some student is asking that this class whether this is conducted physically too. No, this class is totally conducted on online. Our physical classes are there, but only in Pandura and Horna, right? So this is only conducted online and totally we'll complete the syllabus, right? So no worries about that thing. This is the class time, right? 8 to 10:30. It may be after 6 months. It may be 10 to 11 as well, right? Okay, let's begin. The atomic structure. Okay, as I said earlier, this is the story of the atom, right? Let's start about hearing the story of the atom, right? Some ancient stuff, right? Okay, first of all, before going to the atom, right, how this atom concept came to the world. That is the idea, right? So actually universe, when it comes to the universe, right, universe is made out of 2 things. One is matter and the other one is energy. Matter and energy combination gives us the universe, right? Actually chemistry means the study of matter, right? The study of energy is actually belongs to the physics stuff. Kinetic energies, potential energies, right? The electrical energies, those belongs to your physics lessons. here with chemistry, right, we are mostly dealing with the matter, right? So when it comes to matter, it is very important to know about the atom, right? Let's begin with that. The concept of atom, right? So the concept of atom is first came by the Greek philosophers and Democritus, right? So that concept is like this, Lamai, right? They came up with this kind of idea, right? So if you are to take a matter particle, if you take a matter particle like this, let's take a matter particle like this, right? And if you are to divide that thing, if you divide that thing into half and continue that process, dividing the matter particle into halves, so obtained half will be divided into another half. If you do this process continuously like this, right, you will come up with a matter particle which will be no longer divisible, uncuttable, indivisible matter particle you will find. That matter particle is called as the atomos or the atom. Atomos in Greek or the atom in English. Right? So that is how the atom concept came to our world. So the concept of atom is actually first put forward by the Greek philosophers and the Democritus. You should know that thing, right? Democritus and the Greek philosophers are the ones first put forward the concept of atoms, right? Okay, so let's you can go through the tute as well. We have provided the tute, right, to clear your class group. But if you have any matter with the tutes, right, and how we are to provide those things, just message our class group there, right? Our team member will conduct that thing, right? So then let's go to the tute, what they say, and continue the lesson, right? So you can go to the tute. It says, right, at the first page, right, it says, introduction. Chemistry is the study of properties and behavior of matter. Matter is the physical material of the universe. It is anything that has mass and occupies space, right? That is all about matter. You know that stuff, right? Then Democritus and other Greek philosophers describe the material world as being made out of tiny, invisible, indivisible particles that they called atoms, meaning indivisible or uncuttable, right? You got the idea, right? These things are at the resource book, Lamai. So what I am doing is actually explaining all the things at the resource book. That is what I am doing, first of all, right? I am going through the lines of those wordings in your resource book. I will explain all the stuff in your resource book. That is the minimum you should know to come up with a better result. Every word in your resource book should be known. I must say that is the minimum you should know to come up with a good result. Minimum, right? That is not the all, that is the minimum. So first we need to know all the stuff at the resource book. So I am trying to explain all those things, right? Okay, right. So next one. So just write there. If you had a hard copy, if you had got a kind of a photocopied stuff for print out, you can write there, right? Origin of the word atom, or the introducing the word atom, is done by Democritus and Greek philosophers. So just write it there with your red color. So you may need some color pins, right? You need some red color, right? Some other colors, green color, some colorful pens to continue this class, right? So so we are going to come up with a very clear, complete note set, right? So you may have to use those colors, and the complete notes are very important. Without a complete, very well organized note, you can't study for your exams, right? So maintain that, right? So the spaces are given in our tutes, so you can use those spaces to write the stuff what I am when I am telling you, right? So, right, then that is all about the history and how the word atom came to our world, right? Then comes the Dalton's turn, right? So Dalton, he's kind of a English teacher actually, right? British English teacher, John Dalton, right? Came up with a precise definition for those atoms. Precise definition, some suggestions. Actually, Dalton came up with 4 suggestions describing the atom. That was the first time who was able to describe the smallest, tiniest, uncuttable, indivisible particle. Then, right? So Dalton came up with 4 postulates or 4 suggestions. Let's discuss about those 4 suggestions. And keep it in mind, all of these 4 suggestions are now rejected. Nowadays, we are not following any of those suggestions, right? So with those suggestions, we'll discuss about the failures as well then. All the 4 suggestions nowadays rejected, right? So we'll discuss with these, right? What are the reasons to reject those points as well, right? Okay. First point, Dalton's 4 postulates or Dalton's 4 suggestions about the atom, right? First thing, okay, Dalton came up with this kind of idea. Dalton said, okay, look, when we are thinking of matter, the uncuttable, indivisible, the tiniest particle is called as the atom. The same thing what Greek philosophers and the Democritus said. That was the first postulate of the Dalton. He accepted that idea of atom, right? This indivisible, tiniest, smallest, uncuttable particle of matter is called as atom. That was Dalton's first idea, right? But nowadays, we reject this idea. Nowadays, we are not following this idea. Why is that? Anyone can come up with a good reasoning why nowadays we reject this one? Yes? You can.
Which is subatomic particles which are smaller than atoms.
Yes, of course, right? Of course. So nowadays we know about the subatomic particles. This is of the subatomic particles: electrons, protons, neutrons. Those are the major stuff, you know, right? Mesons and the stuff are there. Right? Everyone knows about the electrons, protons, and the neutrons. That means the atom can be further divided into those. The atoms can be further divided into electrons, protons, and neutrons. So atom is no longer the uncuttable, indivisible particle of matter that can be cut, that can be divided into neutrons, protons, even as electrons. So that the first idea of Dalton fails with the findings of subatomic particles. Right. Okay? Let's discuss about Dalton's second idea. After discussing all the stuff, we'll write the stuff, right? We'll first discuss, then we'll write, right? Let's think of the second idea. Dalton, what he said. Dalton said, each and every atom of same kind of element is same. What he said? Each and every atom of same element is same, identical with mass and size. Every atom of a single element, every atom of a single element is same, identical with mass and size. Atoms of different elements differ with mass and size. Those are not identical. That was the Dalton's second postulate, second suggestion. And nowadays, again, that idea is not considered as a good one. It failed. Why is that? Why we say that is why we are not going to accept that second idea of Dalton now? You have a chance. ළමයි මොකද කියන්නේ?
Some elements have isotopes, which same elements in different mass numbers.
Yes. The existence of isotopes. Existence of isotopes, right, is a good proof that atoms with same element are with different kind of atoms. So if you take the element carbon, right, not all the carbon atoms are identical. Carbon, this kind of carbon atoms can be seen, carbon 12. You can see the presence of carbon 13 as well as carbon 14. Right? Even with hydrogen, protium, deuterium, tritium, the isotopes, there what happens? The protons number is same. Protons are same, but you are with different numbers of neutrons there. That is why the mass differs. So here, if you are to think of the mass number comes with the summation of protons and neutrons, right? So here you have 6 protons and 6 neutrons to come up with this 12. The atomic number is the number of protons in you, right? So here mass number is 13, that means 6 protons, the atomic number 6 means 6 protons and 7 neutrons. Here 6 protons and 8 neutrons. Right? So you can see the presence of isotopes, which are the different atoms in same element. The same element, carbon, but different atoms. The mass is different because of different amount of neutrons present. Right? So after finding those isotopes, that Dalton's second idea fails. Not even with carbon, but with hydrogen, but with oxygen. Most of the atoms in your periodic table comes up with isotopes. Even the nitrogen. Most of the atoms comes up with isotopes. Atoms with different masses, but those are the atoms of same element. So that says every atom of a single element not going to be the same. So that was what Dalton said. Every atom of a single element should be the same with mass and size. Different elements comes up with different masses. That was Dalton's idea. But with the isotopes, that idea fails. The same atom, but so same element, but different atoms. So Dalton's second postulate failed with the isotopes. Right. The third one. Let's come up with the third postulate of Dalton. Before coming with the third postulate, let's write the stuff. Let's write the first two stuff, and then we'll discuss about the third and fourth postulates of the Dalton and their failures. Right? Let's write the stuff there. Right? Okay. Let's write like this. First of all, it says in your note, let's go to the note. If you have missed anything to grab the stuff, right? Let's go to the note, right? Dalton's atomic model, which is known as the golf ball model, right? The hard sphere, golf ball, right? In 1808, an English scientist, John Dalton, formulated precise definition of atoms, the indivisible building blocks of matter, right? The Dalton's atomic theory was based on 4 postulates, 4 suggestions. Let's write one by one. First 2 things, let's first write, then we'll discuss the third and fourth, and we can write them later, right? Okay, first one, just write with me, right? Number 1, matter is made out of extremely small comma, write it in red color, lamai. Come to your red color pen and write indivisible, come to your normal color pen, particles called, again in red color, atoms. Atoms. That is the Dalton's first postulate. Right? Okay. Put a dash and write the reason why we not believe in that thing nowadays. Put a dash and write with your normal color pen. Just put a dash and write. Presently, this postulate is not accepted. Presently, this postulate is not accepted as presently this postulate is not accepted as, right? Put a comma and write. Now we know the atoms are made out of within brackets, that means can be divided into close the brackets. Come to your red color pen and write subatomic particles again come to your normal color, like electrons, protons, neutrons, etc. Subatomic particles like neutrons, protons, electrons, etc. Right? That was the story of the first postulate of Dalton, the first suggestion. Right now, number two. Just write the second postulate of Dalton. All atoms of a given element are identical. All atoms of a given element are identical. That term identical, just write it in red color. All atoms of a given element are, in red color, right, identical. Right? In mass and size. Again write it in red color, right? Identical in mass and size. First off, the atoms of one element are different from the atoms of all other elements. The atoms of one element are different from the atoms of all other elements. That is also included at the Dalton's second suggestion, right? Right. Then put a dash and write the failure. Of this suggestion, right? Presently, this postulate is not accepted as put a comma and write. Now we know about the existence of write it in red color, isotopes. Now we know about the existence of isotopes. Then you can write what isotopes are Just write, recall some memory from your O levels, right? Okay. Today's lesson is with some of those recalling parts of your O level stuff, right? O level and small ages stuff, right? Okay. So let's discuss about the isotopes, right? We had discussed about the isotopes, right? Let's write this stuff right there, right? In the next line, you can write what isotopes are, right? Just write this. Isotopes are atoms with same amount of protons. Isotopes are atoms with same amount of protons. You see here, right? Same amount of protons, right? In isotopes, always the proton number is same. That means same element means the same amount of protons, right? When the proton number changes, the element changes, right? So isotopes are atoms with same amount of protons. Isotopes are atoms with same amount of protons. Within brackets, so the same element, so the same element, so the same element, so the same element, close the brackets, but with write it in red color, come to your red color pen and write different amount of neutrons, different amount of neutrons, but with different amount of neutrons, different amount of neutrons. So within brackets you can write, so the mass is different, so the mass is different, so the mass is different. So in your atoms, Lamai, in your atoms, mass is carried by the protons and the neutrons, right? Mass is carried by the protons and neutrons, right? Even though electrons are there in your atoms, their masses are negligible. Summation of all the electrons in your atom contribute nothing to its mass, contribute nothing to its mass. Almost all the mass of your atom is carried by the neutrons and protons. Why we say so? Why we say so? It is like this now. In smaller ages you have learned, right? The mass of a proton is actually mass of a proton. If you take the mass of a proton, if you think of a mass of a proton, let's say it is MP, it is equal to 1840 times of 1837, that is okay for, let's say take it as 40 of mass of electrons. Or else you may have learned it as the other way, mass of electron is, if you have to subject that thing, mass of a proton, right, into this amount, right? So the mass of electron is very negligible, very negligible. You need 1840 electrons to give the mass of a proton. You need 1840 electrons to give the mass of a proton. So such amount of electrons are not available in your atoms. Such amount of electrons are not available in your atoms. The maximum number of electrons there could be in an atom is how much? The maximum number of electrons there could be in an atom is 120. 120. Up to date, we have found only up to the 120th element. 120th element means, right, you have only 120 electrons there, right, in that element. So that is the maximum number available for number of electrons. So you can't, even the maximum, even with the atom with maximum number of electrons, right, can't give you a sufficient value, can't contribute sufficiently for the mass of that atom. to provide the mass of a proton, you need 1840 electrons. So remember that mass of an atom is always carried by only the protons and neutrons. The electronic mass is negligible. So as the number of neutrons change, the mass will change. The mass will change. So with the isotopes, you are dealing with different masses. Same element, same proton means same element, but different masses. That is the concept of isotopes, right? So we'll write some isotopes here. We'll copy some isotopes as well, right? Okay. Okay, let's copy some isotopes, right? So let's write few of the isotopes. For Dalia isotopes here, right? So examples for some isotopes, right? Let's write this stuff with me, Raman. For the element hydrogen, we know about hydrogen 1,1 protium. This is deuterium, and tritium is also there. When it comes to carbon, just write with me, Raman. For the element carbon, you can think of carbon 12, carbon 13, carbon 14. Lamai, when representing the isotopes, no need of writing the proton number or the atomic number, because carbon means 6 protons. Carbon means 6 protons. That won't change. That symbol carries the atomic number. So when representing the isotopes, no need of writing the atomic number, right? So just come up with the mass number. Carbon 12, carbon 13, carbon 14. That will be enough. Writing the atomic number is not wrong. That is not wrong. That is okay, but no need, right? So for some other element, for the element oxygen, you have 16 oxygen as well as 18 oxygen, right? Oxygen 16 is the most available oxygen. Oxygen 18 is also there, right? Just write these stuff, Laman. Just write these stuff as some examples for isotopes. Not only these elements, right? Almost all the elements are with carrying some isotopes, right? Okay, just complete this up. This is the story of the Dalton's second postulate, right? Right, no? Okay. Let's discuss about the next postulate of Dalton. Dalton's third postulate. This right now? Okay. Let's start. Dalton's third postulate. Okay. So Dalton said, right? The atoms can't be created nor destroyed. The atoms can't be created nor destroyed. That was Dalton's third idea. If you take an atom, you can't destroy that thing, right? You can't create new atoms out from existing atom. Actually, that is what mass conservation is. Actually, that is what mass conservation is. right, in smaller d's, right, you use that law, the mass conservation law, to balance the chemical equations. To balance the chemical reactions, you had used the mass conservation law. What was that? Mass conservation law is actually like this, no? Mass conservation is actually, right, the all atoms in here at the reactant side should be there at the product side as well. As you have one carbon atom and two oxygen atoms at the reactant side at the beginning of the reaction, at the end of the reaction you should have the same number of carbon atoms and oxygen atoms as well, because atoms can't be created nor destroyed. All atoms you have begin with should be there at the end as well, right? That is the idea, the mass conservation law, right? So this is another reaction, N2 reacting with H2 to come up with the NH3, right? You can balance this stuff, right? You are balancing this stuff using the mass conservation law. That means each and every atom happen to appear at the reactant side, means there was the first there, if they have some atom at the beginning, those atoms should be there at the end as well. That is the idea. That is how you balance this stuff. As we have 6 hydrogen atoms here at the beginning, you should have 6 hydrogen atoms at the end as well. The hydrogen atoms can't be created nor destroyed. You can't have more than 6 hydrogen atoms at the product side. You can't create hydrogen atoms. You can't have less number of hydrogen atoms at the product side. You can't destroy hydrogen atoms. That is the idea. So the atoms can't be created nor destroyed, right? That was Dalton's third postulate, Dalton's third suggestion. Actually, that is very true when it comes to chemical reactions. When it comes to chemical reactions, that is very true. That is what you see. That is why you apply the mass conservation. That is why you apply the mass conservation, right? So that is very true with the chemical reactions. But that fails with physical reactions, means nuclear reactions. In physics we study about nuclear reactions, right? With nuclear reactions, atoms can be created as well as destroyed, right? So we can think of this kind of nuclear reactions, right? Okay, the carbon atom, you will start with carbon atom, carbon 614, right? And you can end up with some nitrogen atom by releasing some beta particle, right? We will discuss about these reactions, we will discuss about these nuclear reactions at the end of this lesson. At the end of this lesson, we have a section called the study of the nucleus. We will discuss how to balance these stuff. But here you clearly see that carbon at the initial state, at the beginning you had carbon, but at the end you don't see the carbon appearing. That means carbon had destroyed at this reaction. And nitrogen appearing at the product side, at the end you see nitrogen is there, but it was not there at the beginning. So with this reaction, nitrogen has been created. So atoms can be created, atoms can be destroyed. So with this kind of nuclear reactions, the Dalton's third postulate fields. Third postulate fields. So let's discuss a bit about this case, right? What are these nuclear reactions and what are the chemical reactions? What are the chemical reactions? These are the chemical reactions. Dalton's idea is okay with the chemical reactions, mass conservation valid, but not with the nuclear reactions. What differs, right, with the nuclear and the chemical reactions, right? Why we won't see the mass conservation? Why we won't see the mass conservation appearing at the nuclear reactions? Any one of you having any idea? What is the difference between the chemical reactions, the mass and the nuclear reactions? What are chemical reactions? So, any one of you having any idea about the chemical reactions? Actually, chemical reactions, at the chemical reactions, only the valence shell participate. The valence shell participate. The electrons at the valence shell participate in those chemical reactions. When it comes to atoms, right, you have the nucleus here. You know about the atoms, right? You have some idea. You have that 288 model. You may have learned at your levels, right? Atom is there. Some electronic shells are there. So when you are to think of chemical reactions or chemical bonding, reactions are like, reactions means the bond breaking and bond forming, no? Reactions means the bonds of the reactants break and the bonds of the products form. It's like that, no? This carbon is like this, oxygen is like this. Bonds of the reactants break to form the bonds of the products. So reaction means a bond breaking and bond forming. These bonds break, bonds at the reactants break, and bonds of the products form. A reaction means bond breaking and bond forming. So bond breaking and bond forming always involves the valence shell of your atoms, valence shell of your atoms, right? When it comes to these atoms, the covalent bonds are formed by your valence shell. Covalent bonds are formed by your valence shell. The sharing pair of electrons belongs to valence shell, the outermost shell. The outermost shell. When it comes to ionic bonds, consider the NaCl, Na plus and the Cl minus. Na plus, you form Na plus by ejecting the electron at the valence shell. The sodium comes with 281. You just remove the electron at the final shell to come up with Na plus. What about the Cl minus? This is how we produce the ionic bond, right? What about the Cl minus? You have, with the Cl, you have 287, chlorine is your 17th atom. You put some one electron there to come up with 18 electrons to produce the Cl minus. So that electron is added to the valence shell to come it as 288, 287 converted to 288, carrying 18 electrons. That is how the Cl minus is formed. Then the ionic bond happens, just involved in the valence shells. So chemical reactions are occurring always with the involvement of valence shell electrons. The change in number of electrons in the valence shell. So I earlier said, there is no contribution for the mass of atoms by the electrons. There is no contribution for the mass of atoms by the electrons. So change in the number of electrons at the valence shell won't change your mass, won't change your mass, won't change your atom. Changing the number of electrons at the valence shell won't change your atom. Proton number won't change by forming chemical bonds. So your atom won't change. That is why at the chemical reactions, you won't see the mass change occurring. Chemical reactions are okay with the Dalton's third postulate. But when it comes to nuclear reactions, what happened? When it comes to nuclear reactions, name carries the answer, nuclear reaction. You can see a change in your nucleus, inside your nucleus. You can see the change of number of particles in your nucleus. Some protons may convert to neutrons. Some neutrons may convert to protons. That was what happened here. See, here you had 6 protons. Here you had 6 protons and 8 neutrons. Here you have 7 protons. Right? 7 protons and 7 neutrons to come up with 14. What happened here? Actually, with this reaction, what happened there is just converting a neutron to a proton. Just converting a neutron to a proton. You had 8 neutrons here, 6 protons. You have 7 protons and 7 neutrons. So with these physical reactions, with these nuclear reactions, you see the conversion of neutrons to protons. Right? So neutron number changes, proton number changes. When the proton number change happens, the atom will destroy it and a new atom will be born. Right? That is why we say, right, in nuclear reactions, definitely the atoms are created and atoms are destroyed, because they are involving with the change of number of nuclear particles. When the number of protons change, the atom will change. The atom carrying 6 protons is the carbon. Atom carrying 7 protons is the nitrogen. If the proton number changes 6 to 7, the carbon will convert to nitrogen. That is the idea. So when it comes to Dalton's third postulate, right, it is okay with the chemical reactions, but it fails with nuclear reactions. So it failed with the nuclear reactions. Right, no? අපි ඒ කතාව ලියා ගමු ළමයි. Let's write the stuff simply. Then we'll continue with the fourth one. Right? Just write the third postulate of the Dalton, number 3. Right? Just write like this. If you have any questions, lamai, first of all, before writing, if you have any questions, just raise your hand and we can answer those. Yes, yes, you can answer with the use of your. You can answer ask questions with the use of your mic. No worries. You can just raise your hands and we'll give you some opportunity to ask questions. No worries. Right now, okay. Let's continue then. Number 3, Dalton's third postulate, right? Okay, let's write. Atoms are. Just write it in red color. Neither created nor destroyed. Neither created nor destroyed. Neither created nor destroyed. Just write that phrase in red color, right? Neither created nor destroyed. Come to your normal color. And write. This means atoms of one element cannot be changed / converted This means atoms of one element cannot be changed / converted into atoms of a different element, into atoms of a different element, right, into atoms of a different element. That was what Dalton suggested. As atoms can't be created, no, as atoms can't be formed, right? That was his idea. Destroyed, sorry. Put a dash and write. Put a dash and write the failure and the remaining stuff there, right? Put a dash and write like this. Even though this is true with chemical reactions, 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 this postulate, write it in red color, does not stand with nuclear reactions, does not stand with nuclear reactions. This postulate does not stand with nuclear reactions. That does not stand with nuclear reactions. Right? So we can come up with some examples, right? We'll write 2 examples here, right? Okay, you can just write these 2, Ramai. This is an example for a chemical reaction, right? This is example for a chemical reaction, and the latter one is kind of example for a nuclear reaction, right? So with the nuclear reactions, you clearly see the atoms have been destroyed as well as created. Right now? These are some examples, right? So Dalton's third postulate is okay with the chemical reactions. All the atoms appearing at the start is there at the end as well. But that fails with the nuclear reactions. You had a carbon atom at the start, but you won't see that appearing at the end. So carbon destroyed. You have a nitrogen atom at the end, but it was not there at the beginning. So nitrogen created. So with nuclear reactions, Dalton's third postulate fails. Atoms can be created and can be destroyed, right? So with nuclear reactions, right? Lamai, earlier days when Dalton said those came up with those postulates, right? They haven't found the nuclear reactions. Such a concept was not there, right? That was the reason. Such a concept was not there. In 1930s, 20s, 30s, they found the nuclear reactions with the atomic bomb stuff, right? Nuclear reactions are born, right? So up to that age, right, they have no knowledge about the nuclear reactions. That was the case, right? So in Dalton's era, they have known only about the chemical reactions. So that for the chemical reactions, that is okay. That is okay, right? With the findings of the nuclear reactions, that fails. Right now? Okay, just write this stuff, right? So basically alpha beta particles, such kind of particles will release when these protons and neutrons convert to each other. Alpha particles, beta particles. We'll discuss about these reactions at the final sections of this lesson. when we are to study the nucleus of the atom, right? Right now, okay. Let's come up with the Dalton's fourth postulate. Let's discuss. Let's discuss Dalton's fourth postulate. Dalton's fourth idea. Yes, that is like this. Dalton said, right? This is all about compounds, Lamai. This is all about compounds. Then, when forming compounds, the atoms are combined. Atoms are to combined with simple integer ratios. Simple integer ratios. That is what Dalton said. When forming compounds, compounds means kind of stuff with more than one kind of atom, no? Species with more than one kind of atom is referred to as compounds, no? Right? Dalton said, when forming compounds, the atoms are joined with simple integer ratios. Simple integer ratios. Let's see. Let's grab that idea first of all. The idea, fourth idea of the Dalton. So normally it is true, no? So when it comes to simple compounds like CO2, you see, when it comes to CO2, the carbon and oxygen are with 1 to 2 ratio. This 1 to 2 ratio is kind of a simple ratio and kind of integer ratio. Simple integer ratio. It is not like 1.5 to 2. It is not like 1.32 to 2. It is not. This is an integer value, not a half value. Simple integer ratios. Let's come up with the NH3. So here the atoms are combined, the nitrogen and hydrogen are combined with 1 to 3 ratio. Simple integer ratios. This is not like 1.5 to 3, no. Decimals are not there. Fractions are not there. Just whole numbers, integer ratios. And those ratios are simple. 1 to 3, kind of a simple ratio. 1 to 2, kind of a simple ratio. Right? That is the idea. Even the H2O, CH4, in H2O, no? So the hydrogen to oxygen ratio is 2 to 1. Integer ratios. No half values, no decimals. Carbon to hydrogen, 1 to 4. Integer ratios, simple integer ratios. Simple ratios, root 1, 1 to 4. So that is the Dalton's idea. When atoms are to combine to form compounds, they will combine with simple integer ratios. Right? That was the Dalton's fourth idea, fourth postulate, the fourth suggestion. But nowadays, that idea is also fused with the simple term. When it comes to compounds, Lamai, always you have to connect with integer ratios. You can't connect half of atoms. Always atoms should be completely connected to each other. You can come up with half atoms. The integer part still appear. But when it comes to some compounds, their ratios are not that much simple. Let's take the sugar. Let's take the sugar like this. This stuff. Right? You see, the ratio is carbon to hydrogen to oxygen ratio is 2L to 22 to 11. Yes, these are integer ratios, no half values, no decimals. But you see, is this a kind of simple ratio? 12 to 11, is it a simple ratio? 12 to 11, 1 to 2, 1 to 3, 2 to 3. Those are simple ratios. We can't say this is a simple ratio. 12 to 11, some large values, yeah. 12 to 11, right? So, this postulate, the half of the postulate is veiled because of this stuff. Yes, the integer ratios are applied still, yet the sum of the, when coming to sum of the stuff, the ratios are not that much simple. Ratios are not that much simple. You can think of hydrocarbons as well. Some hydrocarbons are there, like this. C17H36. These are kind of hydrocarbons. So here the ratio is 17 to 36. It is not simple, right? 17 to 36. Now this problem appears when you have primary numbers. When you have primary numbers with you. When you have primary numbers with you, this problem appears. When you have primary numbers with you, this problem appears. Because you can't further divide that stuff now, right? So the ratios are not that much simple for some compounds, the combining ratios. Anyway, those are integer, right? No worries with that. So half of the postulate fails because of the integer part, whole numbers. Because of the simple part, not because of the integer part, not because, but because of the simple ratios, right? Okay, right. Let's write the stuff there. Just write the things there appearing, right? Okay. Number 4, right? Number 4, the fourth postulate, the story of the fourth postulate of Dalton, right? Just right. Compounds are formed by union of two or more atoms union of two or more atoms of different elements. Compounds are formed by union of two or more atoms of different elements. Two or more atoms of different elements. Two or more atoms of different elements. Inner. Write it in red color. Simple numerical ratio. In a simple numerical ratio. Right? So let's come up with some examples. Right? First you write these 4. That is the concept of simple numerical ratios, right? But then after that we'll write the failures. You can write the failures in a different color, right? But when it comes to these, you can write ratio of 17 to 36. is not that simple. Integer ratios thing always appears, right? You can't combine half of the atoms to form compounds, right? Integer ratios, that part always happens, right? But the simple, sometimes the ratios are not simple. That is the problem, right? When it comes to sugars, ratio of basically this 12 to 11 is not that much simple. Just write those two. Now I forgot to tell you, right? You can ask questions from both the languages, right? So you can use even Sinhala language. So I know only the Sinhala and English, right? So you can ask questions from both the languages, Sinhala as well as English. I will always answer with the English language, right? Because it's an English medium class, right? I hope you can understand, right? So yeah, again I'm telling you, you can ask or you can answer questions in both the languages, Sinhala or English, right? Because I don't know the Tamil, right? Sorry for that, right? So Sinhala or English is okay, right? To answer or yeah, to ask questions, right? So always involved with the interactive sessions, right? So that is how you can present your ideas and present your knowledge, right? And that is how you can confirm your knowledge, right? If you have any doubts, just clarify, clear it at the class, not after the class time, but in the class time, at the class, right? You have to clarify all your questions. That is A levels, not like in O levels, Namai. In O levels, most of the students, what they have done is actually just write all the stuff at your teacher write at the board, just copy all the stuff and go to home and study by heart, memorize the stuff. That is what you have done. Most of you have done at your O levels, at your O levels. But that won't give you any good results in your A levels. You have to clarify all those doubts in the class, at the class. Use that class time to ask questions and clear all your doubts, right? Then easily you can do the studies at home. If not, you will stuck with some points and you can't continue the study with such points, right? So that clarify all the doubts in the class. And always my WhatsApp will be available for questions, right? So if you have any questions, just raise your hand and ask, right, from these sections. So this is all about the Dalton's four postulates, the story of those things, right? If you have any problem, just ask. So here, just writing. It is better to use the mic, Lamai, when asking questions, right? I won't see the chat box properly, right? So both languages are encouraged, right? Right, no? Okay. Let's continue with the next part of the lesson, right? Right. We had just discussed about the Dalton's atom, But Lamai, Dalton's atom had a main failure. Dalton's atom had a huge failure. What was that? It was this. Lamai, those days, right, the scientists or people had seen some relationship of matter with charges. Those days, people, the scientists even, seen some relationship of matter with charges. But Dalton didn't account any point about those charges in your matter, with his atom. Right? See, it's like this now. So if matter particles are to react with or if matter particles are to, right, I mean, feel the existence of charge, if matter particles are, let's see, you have a matter particle here, right? You have a matter particle. Right? Right? If you are to feel the existence of charge, see, minus charge. If you are to feel the existence of charge, that matter particle should also have a charge, no? Right? If matter particles to interact with charges, attract or repel towards charges, right? Matter particles should feel those charges. For that, matter particles should have some charge as well, no? Without some charge nature in this matter, that won't get attracted to the negative charges, no? To attract to the negative charges, you have positive charge in your matter. To attract to positive charges, you should have a negative charge in your matter particles. To feel the existence of charges or interact with charges, matter should also come up with charges inside them. So as matter is made out of atoms, matter is actually a bunch of atoms, no? As matter is made out of atoms, so atoms should have some charge nature. But your Dalton's model didn't account for any charge nature of these atoms. Dalton's model didn't account for any charge nature, appearance of charge nature in the atom. Right? That was a huge problem with the Dalton's model. That was the major failure with the Dalton's model. With the subatomic particles, that was the failure. With the isotopes as well, neutrons, protons stuff, that was the failure, charged particles. Right? So that was a main failure with the Dalton's model. So they have to think of a new model then because of this failure, as Dalton's model didn't account for any charge nature of matter particles, so that the atom, right, that was the failure. So we have gone through we have to think of the charges appearing in the atom, right? Then they have done some experiments to come up with the charges, to find the charges of matter, right? Okay, before coming to that story, the finding of charged particles in your atoms, before going to that story, let's go through some examples where you see the matter is feeling the existence of charges, where the matter is sensitive to charges. Let's come up with those things. You may have learned these things at small ages. Let's come up with 3 evidences which proves that matter is sensitive to charge. That matter is sensitive to charge. 3 evidences. Right? Can you come up with one evidence that matter is sensitive to charge? Matter is interacting with charges. Can you tell me? Any one of you? Can you tell me any reason? Any evidence? Sorry? Sorry? Hydrogen bonds in water molecule. Yeah, that is so due to. Yeah. That is one reasoning. Okay, that is some advanced answer. Right? Any other? Some simple stuff that matter is interacting with charges. When the charges are applied, the matter is changing. When the charges are applied. Yeah, that is all, right? Yeah, but can you come up with some stuff which you have learned in your O levels? All of those things, most of those things are A level stuff. We are going to discuss in the A levels, and even the angle and the delta things are also there at the O level stuff, even, right? But what about the electrolysis and the electrochemical cell processes? There, you clearly see when you are applying some electricity, you can change the state of matter. You can change matter by applying electricity. That is what you have seen with the electrolysis. With electrolysis, you have seen you can change, you can do some changes in matter by applying electricity, by applying charges. Electricity means, now you know it is the electricity means the movement of electrons, right? Movement of electrons. So by applying electricity, by applying charges, you can do a change in matter. So if you are able to do a change in matter, that matter should be sensible or sensitive to the charges. Without the matter is having some sensitivity towards charges, it won't change if you have to apply charges, right? So electrolysis is a good example. Electrochemical cell, that is also a good example. By changing the matter, you can produce electricity. By changing the matter, you see the mass of the cathode increase. The cathodic solid matter, the mass increased. The color of the copper sulfate solution decreased, intensity decreased. So you had seen some changes in matter, which leads to produce electricity, which leads to produce charges. So electrolysis and electrochemical cell, those processes are good examples that matter is sensible or sensitive to charges, right? So another example is actually you have learned in your small ages the static electricity. The concept of static electricity also can be explained only with the use of charged matter. Without charges, you can't explain the concept of static electricity as well. So if you are to rub some woolen cloth on rubber, or sometimes you rub those plastic pins or something in your hair, right? And you can attract the very light paper particles there, no? With those pins, plastic pins, right? Kind of stuff you may have done at the small ages, maybe at grade 8, grade 9, right? So that is the static electricity, and that happens also because of the interaction of matter with charges. Because of that, right? So the matter is sensitive to charges, right? So that matter should have some charges in it, so that the atoms also, right? That is the idea. First, write these things simply, right, and clearly, and we'll discuss more stuff with those stuff, right? Actually, this first day's lesson, with this first day's lesson, I thought of giving you some logical approach to O level stuff as well, right? Like O level without logical approach, you may have studied the electrochemical cell, you may have studied the electrolysis, you may have by heart the stuff, right? The equations and the stuff, right? But I thought of giving some logical approach and see whether how much easy to grab those ideas and actually no need to memorize the stuff, right? So we'll see, right? That is what I am planning here, right? With these processes, reminding you again these processes which you have learned at the smaller ages, right? Okay, let's start off with the static electricity, and let's try to grab some ideas behind that process, right? Okay, first thing, let's go to the note, Lama. Let's go to the note, what they are saying first of all, right? Electric nature of matter. Electric nature of matter. It says, electric nature of matter. Even though Dalton's theory described the atoms as the fundamental components of matter, it doesn't account for some of the electric or the charge properties associated with matter, and so the atom. See, these are some evidences. Number one, electric nature of matter due to friction. Electric nature of matter due to friction, right? So let's write this stuff. These are some stuff you may have heard in your small ages, right? Just write this stuff to complete the note, and I'll explain a bit more after writing these things, right? Okay, just write electric nature of matter due to friction. First, you can put a dash and write in red color static electricity. The concept is that. Put a dash and write in red color static electricity. Static electricity. That is the concept, right? That is this concept simply. Right? Just write this thing, Laman. After that, we will discuss. When a glass rod was rubbed on a silk cloth, both will get charged. Both will get charged. At the next line, just write. Similarly, a rubber rod, when rubbed on a woolen cloth, they also get charged. Right? Let's get the idea here. How this happened. Let's get the idea how this happened. Right? So when you are rubbing a rubber rod, when you are rubbing a glass rod on silk, right? Let's discuss about the mechanism to charge this silk and glass. What happens is actually, now we know that electrons are there in all the particles, in all the matter particles. Electrons are there, protons are there, protons are there, right? So what will happen? Electrons from this glass will travel to silk cloth. Electron from this glass will travel to silk cloth like this, so that the silk cloth will get charged as minus, because at the start silk is with same number of protons as well as same number of electrons, so that the silk is neutral at the start. When you are rubbing your glass rod on the silk cloth, the electrons in your glass rod get ejected and came to the silk cloth, so that now you have more electrons, more negative charges than the protons in your silk. So silk gets some negative charge like that, right? When the electrons are ejected from the glass, it will get a positive charge. It will get a positive charge. It will get a positive charge. Why is that? Why is that? Earlier, with the glass, you had same number of electrons as well as protons, the neutral atoms. But when you are rubbing the glass over silk, the electrons of this glass rod have moved to the silk. So number of electrons here, number of negative particles here at the glass rod is now less than the number of positive particles, which are the protons, at the glass. So you have more protons here, less electrons here now. So the charge of the protons will pronounced, can be seen as positive. That is why the glass rod is positively charged. So that this rubbing process gave some charged nature to glass and silk, right? Okay, any question to ask? I expect you to ask a question. So, anyone with a good question? හොඳ question එකක් මම බලාපොරොත්තු වෙනවා with this explanation. If you are not asking questions, I am going to ask a question, right? Okay. So tell me, yes, any question? Yeah.
This change the atomic structure of the glass, since the electrons are lost, and since the electrons are lost to the cloth, how will it get the electrons back? Will it forever be lost?
Yes, a good question. A good question. A good question. Your friend is asking, as this glass thing lost some electrons, it is positively charged, right? Is it going to remain same as positively charged throughout the time? That was the question. Or how it gathers some electrons to get neutralized again? That is the problem, right? Okay. So this is not going to be a huge charge, first of all. This is not going to be a very huge charge generating here. Very few electrons have moved to this thing, right? Some slight charge is generating there, right? Some slight charge is generating there. So think of you are to put this one in a wood in your on your table. So this is positively charged, yeah? So what you are doing now is just keep this thing in your table. Just keeping that thing in your table. It's positively charged. So what will happen? So table is also with electrons. Table will also with electrons. So this thing will attract electrons from the table. Very simple idea. This thing will attract few electrons from the table. And get neutralized. right? Then one may ask that, yes, what happens to the table then, right? Okay, that is connected to the earth. It will grab very few electrons from the earth to neutralize itself. Earth won't feel that removal of very little electrons from it. දැන් ළමයි සාමාන්‍ය if you have a very huge stuff, removal of very few won't be affected to the large stuff. But if you have a very small stuff, removal of few will affect that thing, the properties of that thing. So the charges will be neutralized very easily. The removed charges will be neutralized, right? So that is what happens, right? If not, if you are right, if you are, let's say, if you are not going to put this in on a table, what you are doing is just hanging that thing on your ceiling. You put something like that. Let's say you are not going to put this in a table, and you just hanging the stuff like this. Then its charge won't cancel off that much easily, right? Even you can repel some other glass rod formed like this if you are hanging that thing in your ceiling. Those repulsions will occur. So, but normally, as you are to put that thing on table or something, the charges will neutralize like this. Right? Most of the time, when you are to grab the stuff, it will attract electrons from us and get neutralized. Right? The next question, I think you got the answer. The next question is why we are saying that electrons are the ones moving. Why we say that electrons are the ones moving. To get a negative charge here and a positive charge here, one can argue the protons here move to here. The protons in your silk move to the glass. One can argue like that as well. Why we always say that electrons are the ones moving from the glass to the silk to get a negative charge, to give a negative charge to silk and a positive charge to glass? I think you understood my question, right? If your younger brother come and ask you, hey brother, here, why you say the electrons are moving? I am saying that protons are the ones which move from silk to glass. So protons are positively charged, so that as they are moving from here to here, as this guy glass is with more protons, it will be positively charged, and silk is with less protons, it will get a negative charge. Right? If your younger brother said like that, what is your answer? Can it be the reason? Can it also be a reason to get the two masses, the charges like this? Yeah, you can answer. Why we say that only the electrons are moving? Any idea? අය අපි කියන්නේ electrons මේ යනවා කියලා. Because lamai, electrons are very lighter particles. Those are lightest particles. And when it comes to atoms, those are at the outermost structure of the atom. It can be easily removed. The neutrons and protons are at the core of the atom. So electrons can be easily removed. And as they are at the outermost surface of the atom, as well as those are very light. This mass is 1/1840 times of the protonic mass, very lighter particle. That is one thing. That is one reason why we are saying that electrons are the ones get moved from one place to the other place. That is one reason. The second reason is why we are saying so. The second reason is if the protons are the ones to move from here to here, if the protons are the ones to move from here to here to get a positive, to give a positive charge here and a negative charge here, if the protons are the ones to move from here to here,
It will be nuclear reaction.
okay, right, okay, you are going with some maybe, right, some extreme ideas. Okay, it will be nucleus and not the, but let's say you have to give that idea to a younger child, your small child, your younger brother, without using nuclear stuff, right? Okay, yeah, that is right. It's right. It can be something, but let's say yeah, it can be a problem, right? The protons are moving. The simplest point is if the protons are to move, you should see some mass difference between these two guys. That is the simplest explanation. If protons to move from here to here, mass of this silk should drop and the mass of glass should increase. Do you see such kind of a thing like in electrolysis, like in electrochemical cell? Do you see such kind of a mass increasement with glass? Some mass drop with silk? Silk, some of the silk is not there now. Mass has been dropped. Glass gets some mass like this. Do you see such kind of thing appears? No, that won't happen, no? You won't observe that. Because if the more protons are moving, neutrons or the nuclear particles are moving, so definitely mass change should occur. That is not what happens. That is not what you observe. So definitely it should be the lightest particles in your atoms to move from one place to the other, right? Those are the electrons. Right? So that is your conclusion. Right? That is why we say that the electrons are the ones which move from silk to glass to silk, right? So that is the idea. So such a way, these glass rods and silk clothes get charged through such a case unity. So explain these concepts, explain these observations. There should be some charge nature in matter, so that there should be some charge nature in atom, because matter particles are made out of atoms. But Dalton failed to account for any of those charge nature in those atoms. That was a huge failure, right? So I'll come up with these ones as well, right? The charges of these ones. When it comes to wool and rubber, right? Woolen things get charged as positive, and the rubber will get charged as negative, right? They are actually the charges move from the negative charges, the electrons move from here to here, right? Here the electrons move from here to here. Got the idea? So you can have you can draw these two things, right? Lama, we are expecting you to study with that extent, with always with the reasonings, not just accept what I am saying, not just accept what book says, just think of reasons. That is the way, right? You should study for A levels. Then you will feel the subject in you. Then you can answer the questions without thinking of the teacher, without thinking of the sir, without thinking of the book. You are just able to write whatever you think, and that will be the correct answer if the subject is in you. This is the way you should study for that, right? Okay, now you can do these two stuff, right? That whole space can be used, right? Right, no, hurry. Let's discuss a bit more. Let's discuss a bit more about this stuff, right? Okay, so another thing. Tell me two methods. Tell me two methods. Tell me two methods to confirm that these glass rods and the rubber things get charged. Tell me a method. Actually, there are two methods. Tell me one method first of all to confirm that glass rod get a charge. It may be a negative or positive, no worries, right? It is charged. How do you confirm that glass rod get a? Sorry. Yes.
By getting it closer to a magnet, whether it is a repulsion or an attraction, we can see what charge it gets.
To a magnet, that is not the best way. Charges to a magnet, no. Charges are not attracted. Charges are actually not attracting to the magnets, right? Charges deflect. Charges will change their direction of movements in the presence of magnetic fields, but not attracting to any of the poles. They will just change the direction of their movement, right? But so for that you have to come up with moving charges. Without moving charges, you can't use that technique. So that is not good for this one. This is a kind of a large particle, not like electrons, right? You have discussed these methods in your O levels, in your small ages. That is why I am asking this thing to come up with some idea about this small stuff as well. So one way is what I have done earlier. One thing is what I have done earlier. You can come up with two glass rods like this. You can charge, no, by rubbing silk cloth, you can charge glass rods. Let's come up with two glass rods and hang those things. Hang those things like this. And see whether you see a attraction or repulsion. It should be a repulsion. So whether something happens. You know, actually these things will repel. These things will repel. Why is that? Because these guys are charged. The positive ones will repel from the positive ones. If those are not going to repel, we can say those are uncharged. If repulsions occur, those are charged. Very easy. Right? Opposite charges repel. So you can use this. Just hang the two ones and put them close. Repulsions will occur. Right? Okay. So that is the simplest way to think of charged nature. I mean, that is the simplest way to confirm that your particle is with a charge. Right? That your particle is with a charge. Right. Another method is there. That was there in your smaller days books, right? To confirm the charges. You can use a gold leaf apparatus. Do you remember? Gold leaf apparatus? Anyone? So gold leaf apparatus is the best way to confirm your charge. Lamai, all of these things will be taught in your physics lessons. More practicals on gold leaf apparatus to be done with the 5th unit, electricity. Right? So those are there in your LOs, right? You can't erase those things from your memory and go forward, right? All things are connected ultimately, right? So gold leaf apparatus. Let's refresh our memory about the gold leaf apparatus. Right? Let's refresh our memory about the gold leaf apparatus. Do you have any idea how it works? How the gold leaf apparatus work? Yes. So it's like this. So gold leaf apparatus is kind of this, right? You have apparatus like this. Right? And you have very thin gold leaf here. Very thin gold leaf here connected to here. Right? This is used to come up with charge particles. I mean, confirm the charges, confirm whether your particle is charged or uncharged, and confirm the type of charge, whether it is positively charged or negatively charged. This apparatus is used. Gold leaf apparatus. You may have heard about this. This thing was there in your small ages science book, right? You will remember. Gold leaf apparatus. How it works? See, the thing is this. So if you put this glass rod here, what will happen? This is positively charged. That will attract the electrons from here. So that now this metal is with lack of electrons. So that metal will be positively charged. The metal is with lack of electrons. This metal is with lack of electrons because electrons are attracted to neutralize this positive charge of your glass rod. And this charge comes to this light gold leaf as well. As metals, no, charges will distribute. So what will happen? As these two things are positively charged and closer by, this positive charge will repel with this positive charge, right? So this lighter gold leaf will repel from this positive charge, mass positive charge. So it will look like this. So the gold leaf, right, will repel if the thing is charged. Even if negative charge, this thing will happen because those two guys are getting the same charge. This is how gold leaf apparatus work. If no charge here, as you are not rubbing here, as you are not trying to rub the stuff at the metal here, no electrons will be ejected to this one. If no charge here. So this thing is neutralized, neutral. So that this deviation won't happen if this guy is without a charge. So only if this guy is charged, this kind of variation will occur. Actually, this gold leaf thing can be used to confirm the charge as well. Right? This thing can be used to confirm the charge as well, which is whether it is positive or negative. Right? So I keep it to you how to confirm the charge. Right? Just go to these things, right, and learn some, right, and come up with good answers at the next class. How we can use the gold leaf apparatus to confirm the charge, whether it is positive or negative, right? That is for you to think, right? Okay, that is all about the static electricity. Static electricity proves that there is some charged nature in matter. There is some charged nature in matter. That was a main failure with the Daltons, again I am telling you, right? Okay. those about the static electricity concept, right? So I thought of giving you some ideas about the concepts you have learned earlier, right? But this is the A level view of the static electricity, not the small ages view. This is all about the A level, advanced level view of the static electricity. So you have to take that, grab those ideas like that, right? Like this, right? To get some good results in your A levels, right? Okay, no? Right. අපි යමුද ඊළඟ section එක. Let's go to the next section, right? So this is one thing, right? That proves that matter is having some charged nature. Let's think of discuss about the second proof that matter is sensitive to charge, or matter is able to do some changes when the charge is applied, right? See, that is about the electrolysis. Let's discuss about the electrolysis process, right? Okay, now we are leading to that case, right? The process of electrolysis, right? If you have any doubts with the static electricity thing, you can still ask, right? Any questions? No. If any questions come to your mind, right? You can just ask, right? Feel free to ask questions, right? There's always some kind of interactive sessions. Okay, I'll tell you a story. Before going to that, but I'll tell you a story, right? This is all about knowledge. This is all about knowledge, right? I always respect your questions. That is what I need to say here. This story is all about that. Keep in mind, I always respect your questions. I always respect your doubts. There's no thing as like the false questions. There is no thing like that. There's no thing like that mode questions, so වැඩක් නැති questions. Such things are not there. I always respect your questions, right? Just hear the story. ළමයි, if a child, this is small one, right? If a child, right, comes to you and say, if a very little child, say 5-year-old child, if a very 5-year-old child come to you and say, look Ayya, right, look brother, the sun is revolving around us. The sun is going around us. See, the sun is going around us. The small child of 5-year age, if he tells you, what is your comment? Sun is going around us. Sun is going around Earth. That is what that small child sees. See. Is it false? Is it false? Is it a false idea?
Yes.
Why is that?
Because the earth revolves around the sun.
Because Earth revolves around the sun. We know that. Up to our knowledge, that is our knowledge, we know that Earth is revolving around the sun, going around the sun. Right? But to that small 5-year-old child, to his knowledge, to his maximum knowledge, that is what he sees. To his maximum knowledge, with his observation, he says, no, the sun is the one who goes around us. I am saying he is correct. He is correct. He observed and came up with the idea. But I am asking you, any one of you, did you see that the earth is going around the sun? Did you see with your naked eye? Haven't you been in that space to see that thing? No, no. That is how we thought. That is how we thought. Right? We believe that. Do you know, sometimes it could be not the truth. To our maximum knowledge, right, the existence knowledge, we believe, yes, we are going around sun. But it could not be the truth. Maybe we all the things are going around some other thing, not around sun. Something very near to the sun. We all are revolving around that thing, maybe. Or some other movements is happening. We don't know. But to our knowledge, up to the knowledge existing in this world nowadays, we believe that. But remember, right, most of the stuff in your universe, we don't know. Only we know about 4% of the universe. Only we know about the 4% of the universe. The rest of 96% belongs to dark matter and dark energy. We don't know about any of those. So by knowing very small thing, we say, yes, sun, we go around the sun. That is the case. So I believe that. So that, yes, I know some more stuff than you that could be okay. Right? But, or I honor all your questions. When I can honor that son, that little child's statement, I can honor all of your questions. So feel free to ask any question. Right? So this is what we are doing is just helping you to succeed in your life. Right? So, yes, just ask questions. Just argue with me. Don't trust everything I say. That is not the way of learning. Right? You have to argue until you got the idea. Right? That is all. Okay, let's come up with the next one. Right? That is why I am always saying, yeah, if you are not okay with the language, still ask the questions in Sinhala. Still answer my questions in Sinhala. Still ask the questions in Sinhala. No worries, right? Okay. Let's come up with the second point here, right? Quickly, let's discuss about the electrolysis, right? Electrolysis is another concept, right, where we see the interaction of matter with charges, right? Let's discuss the process which you have learned in your O levels, right? With some different view. The same process, I am trying to give you some different view, which will be ultimately leads to no memorizing. Right? Okay. See, let's come up with this stuff, right? Electrolysis of a copper sulfate solution. Electrolysis of a copper sulfate solution, right? Electrolysis of a copper sulfate solution, right? Using some electrodes, right? Okay. Let's use some carbon electrodes. Let's use some carbon electrodes, right? Carbon electrodes are used. We are utilizing some copper sulfate solution. This is our setup. Let's try to grab those ideas here, right? It's a copper sulfate, aqueous solution. We are utilizing that thing, right? Using carbon electrodes, right? Okay. So this is your positive terminal. This is your negative terminal, right? So yeah, that is the solution, right? And this solution is light blue in color. Do you have some blue color? Not appearing, no? So see, this is light blue, right? and say you have used some carbon electrodes. Carbon electrodes. Right. Okay. First of all, tell me the observations you see if you are to come up with this kind of setup. What can you observe if you are to come up with this kind of setup? There are 3 observations. You will be able to treat 3 observations. If you are able to remind them, just tell me what kind of observations you will see with the copper sulfate electrolysis of a copper sulfate solution. Yes? I need your answers, right? Few observations. One thing is,
The reddish brown color that appear in the metal.
yeah, copper. Oh, yeah. You haven't used copper electrode. I went come.
Carbon electrode.
Yeah, at which terminal? At which terminal?
At the negative terminal.
At the negative terminal. Okay, your friend says, yeah. At the negative terminal. See, this is the negative terminal. This is the positive terminal. Some mass will be deposited. Okay, like this. This is one observation. Few other.
Positive terminal will dissolve. The positive terminal will dissolve.
Positive terminal will dissolve if the positive terminal constructed with the copper electrode. But that is not here. It is carbon electrodes, right? So you would see some other observation. So if the dissolving thing with the positive terminal happens, the color of this light blue solution won't change, right? But with this setup, you will see the color of light blue solution eventually drops. Those are three observations are there. First thing is the mass of the negative terminal increases. We'll discuss the reasons behind them. That is A-level stuff, right? Mass of the negative terminal get increased. Color of the copper sulfate solution get decreased. Intensity will decrease. And the third observation is you will see some gas bubble liberation from the anode. Those are the observations. We'll discuss about the reasonings about those observations. Right? First of all, let's discuss about how the mass of the carbon electrode at the negative terminal increased and how the color of the light blue solution decreased. Let's first discuss about those two stuff, then we can think of this one, right? First of all, right, okay, tell me how this process happens. It is like this, Lama, right? All starts with here. As this is negative terminal, right? More electrons are here. This is the battery's negative terminal. More electrons are there. So it will release electrons. It will release electrons from the negative terminal. It will release electrons from the negative terminal. As this is a positive terminal, this thing will attract electrons from the wire. That means ultimately the electrons are removed from the electrode itself. Are you clear with this? Are you clear?
Yes.
Right. Okay. So then now tell me, what is the terminal which undergoes the oxidation? Is the negative terminal or the positive terminal?
Negative.
So, no. Don't memorize. Oxidation means, what is the definition? Removal of electrons means oxidation. Removal of electrons means oxidation. Right? If you have a particle and you remove electrons from that thing, we say this particle has oxidized. Oxidation. Removal of electrons from any particle is oxidation. Right? If the other thing, if you are to grab electrons, if you are to insert electrons to a particle, it is reduction. Absorption of electrons to a particle is reduction. Removal of electrons from a particle is oxidation. So now tell me, which electrode oxidize, which electrode reduce from the definition? You clearly see towards this electrode, towards this negative terminal, the electrodes are approaching, electrons are approaching. So electrons are gathered by this carbon electrode, negative electrode. So the reduction occurs. If the particle, if the electrode accept electrons, the reduction occurs. Accepting electrons, the reduction. As electrons are removing here from this terminal, positive terminal, the oxidation occurs. The oxidation occurs. As electrons are removed, as the electrons are removed from that terminal. Removal of electrons, oxidation. Absorption of electrons, reduction. See, no need to memorize which terminal is to reduce or which terminal is to oxidize. All the things are connected. Because of the battery, these things happen. Battery push some electrons towards this terminal. Battery attract electrons from this terminal. So this is the terminal where you see the oxidation, this is the terminal where you see the reduction. Oxidation, reduction done. No need of memorizing. Right. Then, with that, let's talk about these observations. How you see the increase of mass here and how you see the decreasement of light in color intensity here. It is because of this. Before the proceedings occur, when you are to connect this setup, complete the setup, what will happen? The positive ions in your solution, will attract towards the negative terminal. Positive ions in your solution will attract towards the negative terminal. Opposite charges get attracted. Negative ions in the solution, sulfates, get attracted to positive terminal. This is how the process occurs. If you go through this process, there is nothing to memorize in this whole process. This is what is required at the A levels. I am trying to give you some idea about how you need to study the A level stuff. Right? So, towards negative terminal, the positive particles are attracting. Cations are attracting. Towards the negative terminal, right? So, towards the negative terminal, the positive particles are attracting. Cations are attracting. Towards the positive terminal, the negative particles are attracting. Opposite charges get attracted. Anions are attracting. Right? So, what will happen? So you have more electrons at the negative terminal. So these copper 2 plus ions will absorb those two electrons. Copper 2 plus ions at the aqueous solution will absorb those 2 electrons and produce copper. So with this equation you clearly see the mass conservation and the charge conservation as well. All the chemical equations are like with charge conservation and mass conservation. The mass should be conserved at the start as well as at the end. The charge should be conserved, the net charge is 0 here. Right? This is what happens at the negative electrode. This is what happens at the negative electrode. Right? Because of this solid forming thing, because of this solid forming, here at the negative electrode, we see the mass increasement of the negative electrode. We see the mass increasement of the negative electrode. This is a reduction process. We see the mass increasement of the negative electrode. Right? And because of this aqueous ions get deposited at the negative electrode, because of this aqueous ions get deposited at the negative electrode, your color intensity will decrease. Lamai, copper sulfate is giving you a color, light blue color, because of the copper 2 plus aqueous ions. Because of copper 2 plus aqueous ions, copper sulfate solution is light blue, not because of sulfate ions. Normally D block ions are colored, not the anions involving P block elements. So copper 2 plus ions are the ones which gave you a light blue color to the solution. As copper 2 plus ions, the amount is reducing as those are consuming at the negative electrode. Those are consuming, get reduced with this process. Their color will also drop because the solution gaining a color because of the copper 2 plus ions. Now as copper 2 plus are depositing here, the copper 2 plus ionic amount will decrease at the solution so that its color will decrease. The light blue color will decrease. Right? That is how we explain what you see with this process. Okay. Now tell me, what is the name given to this electrode? Negative electrode. What is the name given to this electrode? Is it the cathode or the anode? Is it the cathode or the anode? The name given to that electrode? Anyone? I am saying nothing to memorize here. Nothing to memorize here.
Negative is the cathode.
Which terminal is the cathode? Negative terminal is the cathode. Yes. Negative terminal is the cathode. By definition, cathode is the terminal where the reduction occurs. Normally we keep it in mind as red cat. Reduction occurs at the cathode. That is the definition. Cathode is the terminal where the reduction occurs. Let's say you have forgotten the definition. You forgot the definition. Right? So how come you are able to assign the cathode and anode? Yes, there is a simple way. The cathode is given its name as cathode because that is the terminal where the cations are get attracted. That is why you label that terminal as the cathode. That is some ancient story. That is why the negative terminal is called as the cathode while the positive particles are called as cations. When it comes to positive particles, those cat thing counts as the positive particles. But with the negative terminal. Why is that? Because of that relationship. cations are attracted to the cathode, so that those should be with opposite charges. Cathode is a terminal where the cations get attracted. So if you know that point, nothing to memorize here, nothing to memorize here. You know the positive particles are called as cations, so cations get attracted to the cathode. Cations get attracted to the cathode. So this is your cathode. This is your cathode. No need to memorize. Anions get attracted to the anode. So your positive terminal should be the anode. As anions are negatively charged, those get attracted to the opposite terminal. So your positive terminal should be the anode. Nothing to memorize. Nothing to memorize. That is what we expect here. Right? Okay. So this is the reaction happens at your cathode. Because of this reaction, the light blue color intensity disappears ultimately, decreases and disappears ultimately. Mass of the product increases. This is solid. Aqueous things happens to become solids. Right? So at the anode, we will see some gas bubble liberations. That is due to the releasement of O2 gas. Right? So we'll discuss about that process at the unit 13. We have to discuss all this stuff in A levels as well, but not now. At the unit 13, we'll discuss that thing. How we are able to produce O2 gas. I'll give you a simple idea. how to produce O2 gas from the sun. Because the copper sulfate solution not only contains copper duplex and sulfate ions. Copper sulfate solutions not only contains copper duplex and sulfate ions. What else the copper sulfate solution contains? What else? Yeah, SO4 minus ions and the copper duplex ions are there in the copper sulfate solution. Not only that, some other species are there. What are they? What is the other kind of species? Sorry? No, the free electrons. But the water molecules. This is not the copper sulfate liquid. This is copper sulfate aqueous. Water molecules. Water molecules are there. So water molecules are also attracting towards the two terminals using their polarities. You know the water molecules are charged. Water molecules are carrying some charges. Like this. Oxygen is negative charge. Hydrogens, you have the positive charge. So water molecules are polar molecules carrying some charges, so that water will also get attracted to here using its positive charge here. The hydrogen get attracted to the cathode using its negative charge here. The oxygen terminal, it get attracted to the anode. So with this oxygen, it is able to produce O2 gas. I'll just write the reaction here. The balancing stuff will be discussed under unit 30, electrochemistry. Right? So that is the idea. Right? So I'll write the two reactions here. You just start writing this whole process. Just start writing this diagram. You can take time. I'll give you some time. So simply draw this picture and get the ideas. If you need, you can put this idea as well, right? The terminal where the oxidation occurs is actually anode. That is definition. Without this definition, you can come up with the anode and cathode, right? Red cat, reduction cathode. Right. Okay. You can draw this one, and I'll write the two reactions here. right now. Just complete the note line. So H2O is carrying some charge nature, right? So with H2O, you produce that O2 gas with use of that oxygen, which ultimately get oxidized. Yeah, look. Right, Lama. You can complete this stuff, right? Complete this note, right? Okay, no? For like, okay. From this one, we'll wind up the lesson for today, right?
Sir, may I leave?
Sorry,
Sir, can I leave? I have written down the notes.
you are done. Is that so?
Yes, I'm done. Can I leave the meeting?
Yeah, you can leave. Right, okay. Lama, let's stop from here. Then goodbye and good night. Right, see you next week then. Right, no? Okay.
Thank you, sir. Good night, sir.
Good night. Right.